We spend endless energy tracking proteins, carbohydrates, and fats. But a horse can survive weeks without a single bite of food. Deprive that same animal of water for just 17 days, and it will die. Water and trace minerals carry exactly 0 calories, yet they dictate the absolute rules of biological survival, operating a hidden system that keeps every organism alive. This data visualization breaks down the composition of the brain's gray matter. The central nervous system is so dependent on hydration that 85% of its physical structure is composed entirely of water. This internal ocean is constantly moving. It is a highly volatile environment, regulated by a microscopic, endless tug-of-war between dissolved elements. To truly understand how bodies function, you have to look past the calorie counts. Survival hinges on maintaining a mathematically precise equilibrium of these opposing chemical forces. Take an animal living in total isolation, wandering a barren desert, or a mammal trapped in hibernation. How do they survive for months without taking a single sip of water? Through metabolic oxidation, breaking down 1 gram of lipid yields exactly 1.97 grams of endogenous water. But there is a paradox. Physical fat tissue is inherently hydrophobic, actively repelling water molecules from its environment. A standard healthy mammal maintains a total body water volume hovering right around 60%. However, in an overfattened sheep, that total body water plummets down to just 35%. The dense accumulation of fat literally displaces the internal water supply. Fat tissue doesn't function as a physical water tank. It acts as a dense battery of chemical potential, a reservoir of hydrogen and oxygen that metabolic oxidation releases into the system as usable water. Zooming in from the whole animal down to the microscopic cellular membrane, a territorial war is playing out between individual ions. Notice that sodium, represented by Na+, completely dominates the extracellular fluids surrounding the cell. Sodium acts as a biological magnet. It aggressively pulls water out of the cell interior and into the surrounding tissues, which is the exact physical mechanism that causes edema or swelling. Looking inside the cell, we find potassium, the K+ symbols, dominating the intracellular fluid. Potassium exerts direct opposing pressure. It pushes water out of the cell's interior, acting as a natural diuretic to resist sodium's pull. If these two specific minerals weren't locked in constant opposing tension, the cell's structure would fail. It would either fatally rupture from the inward swelling or completely collapse from extreme dehydration. Because trace elements exist in such tiny volumes, it is easy to assume they lack the power to impact an entire macroorganism. The moment a pathogen or toxin enters the body, highly reactive copper is instantly mobilized from the liver, deploying straight into the bloodstream. Once in the blood, those copper ions seek out the pathogenic toxins and physically bind to them. This molecular attachment alters their structure, rendering the invaders chemically harmless. Trace minerals do not sit idle as static nutritional building blocks. They function as a highly mobile chemical military force, actively seeking out threats to defend the organism's equilibrium. Every sip of water and bite of food supplies critical ammunition for these microscopic ionic wars, replenishing the chemical stockpile required to maintain control. Biological life functions as a highly calibrated machine of fluid dynamics and electrochemical tension, completely reliant on invisible forces pulling against one another. Survival hinges on the absolute unyielding equilibrium of this mathematically precise internal ocean.